Okay, so before we start doing some more integration techniques, it's useful to recap some of the single mass techniques that you did last year. First off, there's this table with standard results for integration that you are expected to know. So first off, integrating x to the power n. The rule is that you add 1 to the power and you divide by the new power. All of these should have plus c on, but I'm just going to put the standard results on for these. Integrating e to the x just integrates to e to the x. Integrating 1 over x integrates to ln x. It technically should have modular signs around it. In fact, technically this one should be ln ax because any of those will differentiate to 1 over x. But whenever you integrate into ln, it should have modular signs. Integrating a to the x stays as a to the x. However, remember when you differentiate a to the x, you times by ln a. So when you integrate a to the x, you divide by ln a. For integrating trig functions, I'd like to draw a little diagram like this. So sc minus s minus c, going clockwise around that gives you your differentiation results, and going anti-clockwise around that gives you your integration results. So integrating sine goes to minus cos x, integrating cos goes to positive sine x. Integrating sec squared is a standard result that you can use. So because when you differentiate tan x, you get sec squared, vice versa. When you integrate sec squared, you get tan x. And integrating tan x is on your formula sheet. It's either ln sec x, or you can have minus ln. They are equivalent. There's 4 examples down here of kind of reverse chain rule integration techniques. Each of these you can do by a substitution, but it's faster and easier if you can spot the reverse chain rule on these. So this first one, because it's a linear function inside the bracket, we can just integrate sine x as normal, which integrates to minus cos. Because there's a number in front of the x, when we differentiate that 4 would have come out because of the chain rule. So when we integrate, we divide by that 4. So it gives us minus a quarter cos 4x minus 3. These next one here are ones that you can recognize as a reverse chain. So the first one is on the formula sheet. It's of the form f dashed x over f of x. Give or take a numerical factor that we'll deal with. So this one I recognize if I differentiate the bottom of this fraction, I would get 2x. On the top, I've got x, so if I just times that by 2, then that is the form that I want. However, I can't just randomly times this through by 2, so I have to times it by half to kind of account for that too. This is now in the form that we want to integrate this. So now I know this will integrate to just ln of the bottom, because that 2x on the top would have come out from the chain rule, and I've got that half in front. This example here, I recognize that if I differentiate x cubed, I'll get 3x squared, which is basically what we've got at the front here. So let's write it as the power differentiated, so 3x squared, times it by a third to account for that 3 that I've just added in there. And now I can integrate this. So integrating e just stays the same. I don't need to worry about that 3x squared because that came out from the chain rule. But this just integrates to a third e to the x cubed. Finally, this one, before I integrate it, I'm going to rewrite this bracket. I'm going to rewrite the cube root of x squared plus 8 on the bottom as x squared plus 8 to the minus a third. What I noticed about this one is that if I differentiate the inside, I get 2x. So that would come out from the chain rule when I differentiate the original function. So I can just factorize that 2 out to make it 2x at the front. Integrating this now. So I don't need to worry about the 2x because that came out because of the chain rule. So integrating the bracket, I add 1 to the power, 2 over 3, and I divide by the new power. So dividing by 2/3 is the same as timesing by 3 over 3, which will simplify to 3x squared plus 8, and 2/3 plus c. What we're going to learn now is how to apply some more standard results for integration. These results are all on your formula sheet, so you don't need to learn these, but notice they all look very, very similar. They're all fractions with 1 on the top. They've all got some combination of a squared and x squared in various pluses and minus orientations, and some of them have got roots on as well. They all integrate to give slightly different things. So what we're going to do in these is look at some integrals, choose the correct standard result to use for this one. So the first one, we've got 1 over root 25 minus x squared. Having a look at the standard results, I want one that's got a root in, I want one that's got a minus x squared in as well, which will be this first one for arcsine. It's 25 minus x squared, so that's a squared equals 25, so a equals 5. So I can just write down the standard result for this one is arcsine x over 5 plus c. Similarly for the second one, so this is x squared plus 100 on the bottom. So I'm looking for one that doesn't have a root in it and it's got a plus x squared, which is the second one for arc. A this time is 10 because a squared is 100. So I can write down this result, but it's 1 over 10 arc tan x over 10 plus c. Third one, I've got 1 over x squared minus 10. So I want one that doesn't have a third on it and it's got positive x squared minus something else, which is this last one down here. What I notice here is that a squared is 10, so this time a is root 10. So writing down my result for this one, that's 1 over 2 root 10 ln x minus root 10 over x plus root 10 plus t. You could rationalize the denominator on the coefficient at the front, but you don't need to. Now, all of these three so far have just been x squared. If it's not just x squared, if there's a number in front of it, you need to do a bit of rearranging first before you can apply the standard result. So what I'm going to do here is I'm going to factorize out this 9 so that it does end up being just x squared. If I factorize 9 out of the bottom, I'm essentially dividing these terms through by 9. So I get 9 times 4 over 9 minus x squared. I can factorize this 9 out, leaving me with this, and now I can choose the appropriate standard result for this one. So I want one that's not got a square root on the bottom. It's got minus x squared, which is going to be the second to last one. My a squared is 4 over 9 in this case, so my a is 2/3, and so I can just substitute that into my standard result. You can either use the ln one or the arctan one, either is fine in this case. So substituting in a is 2/3, that's 1 over 2 times 2/3. Then ln of a plus x, sorry, so 2/3 plus x over a minus x, and then plus b. Tidy this up a little bit so you get 1 over 12 on the outside. Inside the ln, I'm going to times the top and bottom through by 3 just to make it look a little bit nicer, which gives me this. Next example, we're going to do the same thing. We're going to factorize out this 4, so it just says x squared on the bottom. Factorizing the 4 out, we'll leave a quarter plus x squared. Well, that's square rooted. I can take this 4 out of the square root by square root in the 4 itself, so this will be a half. Then 1 over root a quarter plus x squared. Now that it's just x squared, I can have a look at my standard results, choosing the one with a positive x squared and a square root on the bottom, which is the arcshine result. Notice there's 2 options for this, so you can use arcshine or you can use the ln option. We'll just use arcshine. Our a value this time, so a squared is a quarter, so a is a half, so this is arcshine x over a half. X over a half obviously is 2x. The half arcshine of 2x plus 3. With this one, do the same things we've done before. So I'm going to factorize out the 9. That's dividing this through by 9. I get 25 over 9. Taking the 9 out, I can square root that, and I'm just going to get the root x squared minus 25 over. Now that it's just x squared, I can have a look at my standard results. So I want one that said and it's got positive x squared on it. So this one's going to be our cosh, or the ln form. I'll use our cosh. A squared in this case is 25 over 9, so a is 5 over 3. So this will be third r cosh x over 5 over 3, which I can write as 3x over 5. All the ones that we've done so far have just said 1 on top of the fraction. If it was just any number on the top, you just times your integral through by that. That doesn't change. If you get x involved, though, you need a slightly different approach. So here, because we've got x minus 3 on the top of this fraction, I'm going to split this up into 2 integrals. So x over 25 plus x squared, and then minus 3, also over 25 plus x squared. We can then use different techniques to integrate each part of this. So the first one is one of those ones from single maths, where you recognize that the top is the bottom differentiated. And write this as 2x on the top, and it's half that. This one, I'm going to take the minus 3 out and write this as 1 over 25 plus x squared dx. And we can use a standard result to integrate that. Integrating this one, so the 2x came out because of the chain rule, so I don't need to worry about that. Now this is just ln of the denominator. And this one, have a look at the standard result for this one. So I want one without a third, with a positive x squared, which is going to be the arctan one. In this case, a squared is 25, so a is 5. So this is a fifth arctan x over 5. Obviously, you can write 3 times a fifth as 3. The final examples require us to use completing the square to do this. So we can't use standard results straight off because there's minus 2x in the middle. But if we can complete the square on it, then it's something squared plus something else, and we can use a standard result. Completing the square on this denominator, so half your x term, b minus 1. Square that and take it away. You plus 1 here. There's no number in front of the x, so we don't need to worry about any chain rule repercussions from that. So have a look at your standard results for this one, where we've got something squared plus something else on the bottom, which is going to again be arctan. Our a this time is 1, the squared is 1, but instead of x, we're putting in x minus 1. So this is going to be arctan x minus 1 plus. For the final one, we need to complete the square on this. First thing I'm going to do is factorize the minus out from those 2 terms with x involved. I can then complete the square on what's inside the brackets. So x plus 3 squared. Square that 3 and take it away. Don't try and skip steps here. You now need to expand this with the minus. So you get plus 9 plus 16. Which gives you plus 20. That means we can write this integral as 1 over root. I'm going to write it as 25 minus x plus 3 squared. And now we can apply a standard result for this one. Our a will be 5, and instead of x, we've got x plus 3. The result we're going to use for this one is the top one, because we've got a root and a minus x squared in that one. So that's arc sine x over a, which will give us arc sine x plus 3 over 5 plus. I'll quickly reveal the questions for you. You can pause the video here and have a go at those, but I'll quickly reveal the answers so you can pause on each of them just to check your answer.